Okay, guys, let's go into part 4 of REDOX. Hopefully, you have watched part 3. Now, we're going to go into more difficult things, a bit more challenging. Over here, again, I'm having a cell diagram, which is potassium manganate, acidified potassium manganate, and potassium iodide solution. Potassium iodide solution is colorless, as you all know. We have already discussed this in the previous part lesson. And here, what color is potassium manganate? Potassium manganate, I think all of you know, is purple solution. So it's purple in color, all right? So now, before we even start this, I want to give you a chart. This chart is about what is the oxidation agents, oxidizing agent, which you must know, and generally this is what they're going to ask you in SPM, because it's quite fixed. What is the oxidizing agent? The first oxidizing agent is potassium manganate, acidified, which is purple in color, purple. Number 2, they probably will give you potassium dichromate, Cr2O7 acidified, which is orange in color, orange. This is one of the solutions which is orange in color. Sometimes, but rarely, they might give you potassium chromate, CrO4 acidified, which is yellow, very fluorescent yellow, striking yellow, all right? Then we have chlorine water and bromine water. So generally, one of these 5 only will come out in SPM, others we rarely will come out, all right? So this is where generally will come out, okay? This is the oxidizing agent. And on this side is the reducing agent. Reducing agent. The reducing agent is generally potassium iodide. Reducing agent, all right? Or it can be iron, Fe2 plus. All right? Fe2 plus. So generally this 2 is what they will like to ask. So generally when this question comes out, they will pick and match one of these two. They'll either pick this and this, or this and this, or this and this. They'll pick and match. That's how it has been for the last 15, 20, 30 years. Okay, so they won't complicate things. So I want you to know what is this and what is this. Now, why did I give you this chart? Because this chart simply tells you a reducing agent means will undergo what process? Oxidation process. This chart is very important, please take note. Anything which is oxidation process means it is going to donate electron. Which means the charge will increase. Charge will become more positive. Charge or state of oxidation. State of oxidation will increase. Got it? So over here in the same process, that means here, this will be reduction process. This will be a reduction process. And then you already know is opposite. So here oxidizing agent means it will undergo reduction process. Reduction process means must accept electron. Now why is this important? Because from here you understand that 1, 2, 3, 4, 5, they are all going to accept electron. That means look at this diagram. 1 and 2, which one is going to accept electron? Which one is going to accept electron? Potassium manganate. If potassium manganate is going to accept electron, which means electron must masuk lah. Why? Must come inside. So, which is electron masuk inside means potassium manganate will accept. So over here, potassium iodide, so oxidation process, which means it's going to donate electron. Donate electron means which is going to be here. You following me? So this chart is very important. I want you to make sure you get it into your head. Now, next point, which I'm going to tell you now, which I didn't tell you in the previous videos, is, you see, whichever gives out the electron is going to be called the negative terminal. Because electron comes out from there. If electron enters, then that's going to be called a positive terminal. I hope you're clear. Okay, you're clear so far? Now, next, you're going to get confused here, but let's clear this confusion. Okay, now. In electrolysis, I'm going to put a small note here, okay? Take note. In electrolysis, right here. In electrolysis, the positive terminal is called anode, and the negative terminal is called cathode. Careful, huh? Now, that is for electrolysis. Then we have for this is a cell. A voltaic cell, we call it as voltaic cell. Take note, voltaic cell. In a voltaic cell, the positive terminal is called cathode, and the negative terminal is called anode. Please take note, jangan confuse, do not get confused. Are you okay? Now, so what is the conclusion here? The conclusion here, positive or negative can be anode or cathode. It doesn't matter. Anode doesn't mean positive. Cathode doesn't mean negative. No, it can be both. But what is the definition? How you know something is anode? Simple. Anode is a place where oxidation happens. That means the place where oxidation takes place is called, that means it can be a positive or negative. That means in electrolysis, this is the anode. That means the positive terminal is where the oxidation takes place. What's oxidation? Donate electron. In voltaic cell, the negative is called anode because this is where oxidation takes place. And what is reduction? So the place where reduction is taking place is called cathode. Do not get confused. Now, right now after this, I want you to go back and revise back your electrolysis. Under electrolysis, got voltaic cell, no. Daniel cell and so on. So you need to study electrolysis and then the voltaic cell and then compare both and then compare here again. You got it? Are you okay? All right, next. Let's proceed further. Okay. Now what happens? Over here electron is going out. That means we take iodide. This is the equation. Iodide must give electron to become iodine. And you know this is group 17. Group 17 means must be diatomic times 2. So here's a with times 2, here's a with times 2. So this is now called the equation. And because electron go out, this is the place where oxidation takes place. So since oxidation takes place, this is called anode. Please do not make mistake. This is reduction taking place here. So reduction means what? This is going to be called cathode. Why cathode? Because it's a reduction. I hope you're okay. Are you okay? All right, good. So equation now done. Okay, good. Now next I want to highlight here, this is manganate 7. Now in manganate 7, the charge for mangan, that means this oxidation state for mangan is 7. All right, that means it is 7 plus here. You cannot see it, but when you write like this piece here is 7 plus, positive 7. The oxygen is 2 minus, but times 4. You get negative 8. See, oxygen is always 2 minus. So 2 minus times 4 is negative 8. So when you total it up, 7 plus negative 8, that's how you got negative 1. So negative 1 doesn't belong to oxygen. Negative 1 doesn't belong to this. Negative 1 belongs to the whole thing. You get it? But each one will have its own oxidative state, oxidation state. So magnesium actually, manganese, the charge is here is 7 plus. So we need to now write equation for manganese, manganate, right? Here. And manganate minus. And it's receiving electrons. But remember, these three, potassium manganate, potassium dichromate, potassium chromate, without acid, it doesn't work. Because acid is needed. It functions like somewhat like a catalyst, okay? So the acid must be there. So therefore, you must write the acid equation. And then it is accepting electrons. It's accepting electrons. And therefore, it will now, I'm going to erase this stuff because you already know it's oxidation. So this side is called anode, okay, oxidation, okay, right? Now this purple is going to become colorless after the reaction. And here, beginning is colorless, but colorless is going to become, just now we learned, yellowish brown. So now, why is it colorless? Because the colorless is actually being formed by the new manganate, which is Mn2 plus. So the Mn2 plus is colorless, which means here Mn2 plus will be formed. Then there's H and O, so which means it's going to form water. That's it. Are you following me? Come on, think again. How did I get 2 plus? Originally was 7 plus inside. 7 plus will change into 2 plus. Ini kena hafal lah, you must remember. Okay? For time being, you need to remember that it becomes 2 plus. So generally, this has come out, say, about 2 times in the last 10 years. So, okay? So you need to remember. Might be asked again this year. So now, we have 2 equations. One is happening at the anode, and this is happening at the cathode. Anode will donate electrons. Cathode accepting electrons. Are you okay about this? No. Next, once we have done this, we need to make the ionic equation, the complete equation. But before we do the ionic equation, look, this is not balanced. It is not balanced. So now we need to balance it. Now, how do we balance it? Very simple. Let's take a look. Just now I told you this is, let's check first. How many Mn is here? 1 Mn. 1 Mn. Mn is balanced. But H, oxygen got 4. So therefore, we need 4 oxygen here. Let's put 4 oxygen here. But if you put 4 oxygen here, the hydrogen becomes 8. So we need 8 hydrogen. So therefore, let's put 8 hydrogens. You okay? Good. Next, we need to put how many electrons has been accepted. How do we know? Very simple. Now, because originally, mangan here is 7 plus. But finally, the mangan has become 2 plus. See, that means 7 has become 2. How many electrons did it accept? 7. Jatuh 2. It means how many accepted? That means the 7 has accepted 5 electrons, 5 negative. 7 minus 5 is 2. That means it has accepted 5. So this is how you determine the number of electrons accepted in an equation. Are you following me? Okay? So that means we have 2 equations. The first equation is about iodide. Erase all this, huh? Okay. The first equation is about iodide, which has accepted 2 electrons. Then the manganate has accepted 5 electrons. And let's recheck again. How many mangan is there? 1, good. How many hydrogen is there? 8, good. How many oxygen is there? 4, perfect. Let's check whether this is correct or not. How we know? So to know that, you need to check the total charge left and right. Here got -1. Here got +8. Here's 5 negative, so -5. Total how much? -1 plus 8 minus 5, you get -1, +2. On this side, how many? Positive 2 also. Which means now our charge is also balanced. So as I told you, in this chapter, you must balance the atom and you must also balance the charge. Are you okay? Everybody's okay here? All right? So if you're not sure, you can always WhatsApp me and ask, show which one is not clear, and then I will explain to you through the WhatsApp. All right? Everybody's got my number, right? Everybody's got my number, right? So what's my number? 013-364-28885. All right, take it down because I'm going to erase it. All right? So call me. Don't call. WhatsApp. Okay? WhatsApp. Okay, done. Next. So now we must do a simultaneous equation to get rid of the electron, but this is 5 and 2 is not balanced. I must make it times 5 times 2. Make it 10. So that means if you rewrite again, this one you will times by 5 and this one let's times by 2. Am I right? Okay. So here you times by 5, you're going to get 10 iodine. 5 iodine here. This is 10 iodide, 5 iodine, 10 electrons. Okay? Correct? Are you getting it? You better write down. No, stop the video and write it down. Balance it yourself. You don't copy. Now next, you times 2 here. So I'm going to times 2 here. 5MnO4 times 2 here, 16 hydrogens, times 2 here, 10 electrons, times 2 here, 2Mn2 plus and 8H2O. Now, electrons are balanced. Batal. At the left side, which is left side now? This is the arrow. Left side, all this is left. These three will join together. Now, which is the right side? This one, the electron batal radio, batal. So left, right hand side, and the right hand side right together. So that is your answer. Are you getting it? So this is how we write manganate. Potassium manganate. So let's write it down. So 10I minus 2MnO4 minus. Are you okay? Okay. Right? And then 16 hydrogen, 2Mn2 plus 8H2O plus 5I2. Okay. So this is your final answer. Okay. See whether you can simplify. You can't, so leave your answer like this. Are you okay? You all right? So everybody's okay? Okay, let's recheck again. Here I times 5, right? I times 5, I times 5. Good. Here I times 2. Why I times 2? Because I want to make this into 10. So times 2, times 2, times 2, times 2, times 2. Okay? Then I add up all the left sides. This plus this plus this will give you electrons batal, right hand side, right hand side, right hand side. Okay. So this is your final cell equation. All right? Which you need to understand. Are you okay? So the electrons are moving here. So if the electrons move on this side, then current normally moves the other side. Okay? So current will move this side. Are you